When do you use absolute value with radical variables? Imagine you're solving a problem with square roots and variables, but you're unsure whether to include absolute value signs. It can be confusing, but understanding when to use absolute value makes your algebra much clearer. Let's explore this together. Radicals are expressions with roots, like square roots or cube roots. When variables are inside radicals, simplifying often involves rewriting powers outside the radical. For example, the square root of a variable squared simplifies to the absolute value of that variable. This is because square roots always give non-negative results. Think about the difference between even and odd roots. Even roots, like square roots or fourth roots, always produce non-negative answers. Odd roots, like cube roots or fifth roots, can be negative or positive because they preserve the sign of the original number. Now, when do you need absolute value? It mainly happens with even roots. If you have an even root and the variable outside the radical has an odd exponent, you must include absolute value signs. This is because raising a negative number to an odd power keeps it negative, but the radical must be non-negative. So, to keep the expression correct, you write the variable in absolute value. For example, take the square root of a variable squared. The square root of x squared is written as x. If x is negative, x squared becomes positive, but the square root must be positive or 0. The absolute value ensures the expression correctly represents the principal root. On the other hand, if the root is odd, like the cube root of x cubed, you do not need absolute value because the cube root of a negative number is negative. For example, the cube root of -8 is -2. The sign is preserved naturally, so absolute value isn't necessary. Similarly, if the variable outside the radical has an even exponent, absolute value isn't needed because an even power always results in a positive number or 0. For instance, the square root of x4 simplifies to x2, and there's no need for absolute value because x4 is always positive. Let's look at a practical example. Simplify the radical expression, the square root of 16x 10y4. First, simplify each part. The square root of 16 is 4. The square root of x10 is x5, since 10 divided by 2 is 5. The square root of y4 is y2. Because 10 is even but the exponent outside is 5, which is odd, and the root is even, we write x5 with absolute value signs if needed. But since 5 is odd, we write it as x5. In summary, use absolute value with variables outside an even root when the variable has an odd exponent. This ensures the expression stays true to the rule that radicals with even indices always produce non-negative results. Remember, understanding when to include absolute value signs helps keep your algebra correct and makes solving equations much easier.